Start recording. We will turn this on. All right. Hello, everyone. 1 second. Chat. Perfect. Okay. Make sure that that's on the screen. All right. Welcome to workshop number 2 for our Git and GitHub crash course. The purpose of this workshop is really to give you sort of an introductory level into how to use Git, how to use GitHub, how to collaborate with a team. Really, with this being intended to effectively prep our hackathon participants for their collaboration projects next month. But because it's such valuable information, I wanted to open it up to our entire community. So here we are. So let me get everything ready. We need this, and I need a terminal, and I need to share the screen. All right. So in order to dive into this, let's first understand what a repository is. A repository can be considered to be a box, and it holds all of the code, all of the files, all of the assets, pictures, everything, documentation, anything related to your project can go in your repository. And so you can kind of think of it like a folder. And there are essentially two types of repositories. You have a remote repository, which is something on a cloud service like GitHub, and then a local repository, which is something that you would have on your computer. To get started here, let's go ahead and create a repository, a remote repository here on GitHub. So we are going to hit the new repository button. And we are taken to our new repository screen. I really need to make this full screen. 1 second. Okay. On our new repository screen, we see a few options here. So let's go ahead and take a look at some of those. Our first option is going to be a template. You can set up template repositories that contain all of your basic files, like your readme, your license, your code of conduct, and whatnot. And if you have one of those, you could choose from it here. If I click this drop down, you'll see the templates that we use at freeCodeCamp and the templates that we use that I use at Deepgram, because I have access to those organizations. None of those are what we want to use for this repository. So for now, we are going to leave this as no template. Then you'll get the option to decide your owner. Excuse me. It can either be a repository that you own, so in my case, Naomi LGBT, or it can be a repository you create under an organization where you have access. You'll see the few organizations that I am a member of, but you'll notice that the freeCodeCamp organization says insufficient permission, because at freeCodeCamp we do not allow our team to create arbitrary repositories. We have a process for that. Which is okay, because we do not want to make this under the freeCodeCamp organization. We want to put this under my organization. And then we need to define a name for the repository. In this case, we are going to call it freeCodeCamp GitHub Workshop 2, because we had Workshop 1 this morning. And then you provide a description, and the description shows up on the repository's homepage and in the repository list. So it's good to write a little something here that sort of describes your project. So in this case, we will say example repository for the second Git and GitHub workshop at freeCodeCamp. Your next option is going to be to choose the visibility. A private repository starts only visible to you or only visible to the people with special access in an organization. A public repository can be seen by anyone, but does not necessarily mean they can push to the repository. And we'll cover that more a little later. But for the purposes of this workshop, we want this to be a public repository so that any of you can see it too. And then you'll see a few options here to initialize this repository with specific files. The first one is the readme file. And the readme file can be thought of as sort of your entry point document for your project. It shows up on the repository homepage, and it tends to be the first thing that people look at when they are looking at your project. A typical README might include a description of the project, how to set it up locally, how to use it if you host it somewhere, and how basic level of how to contribute. There's other stuff you can stick in there too, and as you sort of learn how you develop your own projects, you'll start to understand what you want in your READMEs. We do want to start this project off with a README, so we are going to go ahead and tick the box. Your next option is a git ignore template. Now, a git ignore is a special file that allows you to tell Git to stop tracking specific things. So you might use a git ignore file to ignore the node modules directory if you're working with a Node.js project, or you might choose to ignore the venv directory if you're working with a Python virtual environment. GitHub will offer you some very decent starting points for pretty much anything you could really think of. They have a very extensive list. But for the purposes of this demo, we do not need a git ignore at all, so we leave that blank. The third option that you get is to choose a license. Now, when it comes to choosing a license, it's important to remember that this is effectively a legally binding document that dictates how people can use your software and what they can do with it. Some examples for that might be the BSD 3 clause license, which is what freeCodeCamp uses, and tends to be very permissive in terms of what someone is allowed to do with that code. On the other side of the spectrum, you have something like the GNU Afro public license, or the GPL, which is very restrictive. For example, any modifications have to be made open source under the same license. So you're effectively saying, for example, that I could not come along, take your code, turn it into my own product, closed source it, and sell it, because your license does not allow that, and if I did that, you would be able to come after me legally. For now, we are going to leave this blank. There's a lot of information out there for what licenses to choose, and I highly recommend you all do some of your own exploring. Finally, you'll see an option to add marketplace apps to your repository. There's a very good chance that for most of you, there will be nothing here. But if you have installed something like DeepSource or like Renovate or like SonarCloud that has access to all of your repositories in the organization, for example, like mine, you can't turn it off. And that's okay. DeepSource is just one of those cool code scanning tools. It can sit there. It's not going to do a whole lot for this. So let's go ahead and create the repository. And when we create the repository, we are automatically redirected to the repository homepage. You can see the name. You can see our description over in the corner. And then you can see our README, which GitHub puts front and center when we're on the repository homepage, which is why having a detailed README is so important. It's kind of your first impression for the project. This README isn't great, though. So let's go ahead and edit it. The first thing we're going to do is make the title look like an actual title. In order to do that, let's go ahead and edit it right here on GitHub. We can click the little pencil icon here, and we will be taken to a very basic editor. We're going to change the title to freeCodeCamp GitHub Workshop 2. That's it. That's all we're going to change for right now, because that's a good change to make. Now, in order to keep this change, we have to make what's called a commit. And a commit in Git can be considered a snapshot of your code state at any given point in time. So when we make this commit, we're going to tell Git to save this current state of this README as part of the history. When we make this commit, we're going to get this super helpful UI. And there's a couple of things to consider here. Your commit message is very much the most important part of this. It's sort of the short description of the changes you make that will show up in the history, will show up on the homepage, will show up in a pull request. So it's really important to be detailed but concise here. I use, but we also use at freeCodeCamp, the conventional commit standards. And the conventional commit standards effectively dictate a specific way to write commits. And they start with the type of commit. Because we are editing the README, this is going to be a docs commit. We add a colon after the type, and then we're going to add a quick description of the changes we are making. In this case, we will say properly title case the title. Let's say the README title. And then under that, you have the extended description. This is where you can get a little bit more detailed. I like to use the description for things like if the approach I am taking needs some extra explanation, I want that in the commit so that, 5 years down the road when somebody looks at the changes I made, they can understand why. It's also a good place for some of the automated things like when you squash a commit or when you revert something. You'll see as we kind of go through this workshop where sometimes some extra information gets added to this description for you. For now, we can go ahead and write something very quick. Let's say the title was originally kebab cased based on the repository name. This is incorrect, and the title should follow standard casing conventions. We're also going to play a game of how many typos can Naomi make today. All right, so we have our message, we have our description, and then finally, you may see an email drop down. And typically, you'll only have one email address here. You'll have the email associated with your account. In my case, I use a dedicated email address for all of my commits, and that is separate from the email address I use to log in. So I want to change that to be my commits email. Finally, you can commit directly to the main branch, which means we just put these changes right on our default branch. Or you can make a new branch and start a pull request. Let's go ahead and put this right on the main branch for now so we can kind of explore some more stuff before we get into making pull requests. We're going to go ahead and commit the changes. And we'll be taken to our newly edited file. And you can see the message we used for the commit. If we click the dots here, we can see our full description. And then we can see that our change was made. Let's go back to the home page. On the home page, because this is the most recent commit, we can see the message again, the description again, but you can also see that our title has been properly updated in the README. This is great. This is exactly what we wanted. But now we want to add some more information to our README. And starting to make bigger changes directly in the web UI can get kind of messy and kind of complicated. So let's work on this locally. In order to work on this locally, we need this repository on our computer. You do this by what's called cloning the repository. And when you clone a repository, you'll click on this code button, and you're going to see a few options here. The first is the HTTPS URL. You would use this to clone the repository, but if you want to do anything that requires authentication, such as committing and pushing, you have to use your GitHub username and a personal access token, which is kind of like an API that is an API key specifically for your account. Your next option is to use SSH. SSH gives you a little more security because instead of having to create an API key or a personal access token, you use your SSH key pair. The way an SSH key pair works is you have a public key, which you'll upload to GitHub in your account settings, and then you'll have a private key, which lives just on your machine, and you should never, ever, ever share it. That private key is how things like GitHub or like how a remote server know who you are. And then the public key tells them what kind of access you have. So if I put my public key on my GitHub, then GitHub can know based on my private key that my computer is authorized to act as me. Your third option is to use the GitHub CLI to clone. We won't really go much into the GitHub CLI specifically because it is great for some things, but as you start to get into more complex stuff, you need to understand Git. And more importantly, the GitHub CLI works for GitHub. Git itself is independent. It works for GitHub. It works for GitLab. It works for Gitee. It works for Codeberg. There are a lot of different options, and understanding Git itself better prepares you for, say, joining a team in your new developer role that uses GitLab instead of GitHub. So for now, we're just going to ignore the GitHub CLI. I do have SSH configured, so we're going to use the SSH URL. We'll go ahead and copy that. Then let's head over to our terminal. And we are going to embiggen the terminal so you all can see it. And we need to put this repository somewhere. I have a dedicated folder I use for temporary stuff like this, so I'm going to switch to that folder now with the cd command, and mine lives in code/temp. If I print the contents, you'll see some stuff I use for other various things, but then you'll also see the workshop directory. And the workshop directory is what I've been using specifically for these courses. So I'm going to change to that directory. And if I print the contents again, you'll see the freeCodeCamp GitHub Workshop 1 repository that I used this morning. We want the second one to be here too. So to do that, we'll take our git clone command, which tells Git to clone the repository from a remote location to our local machine. And then we have to pass the URL. And in this case, we're going to paste the, we are going to paste the SSH URL that we copied. Let's run that. I have to use my 1Password manages my SSH keys. Typically, if you have an SSH key, you would see a password prompt in your terminal. But if we look at this command, we have successfully cloned it. By default, Git will clone the repository into a directory with the same name. Our repository is freeCodeCamp GitHub Workshop 2, so it clones into freeCodeCamp GitHub Workshop 2. If we print the contents of this directory again, you see it right there next to freeCodeCamp GitHub Workshop 1. So let's go ahead and change again to our new cloned repository directory. freeCodeCamp GitHub Workshop 2. Metlo, you would not see an email option if you only have one email address associated with your account. That's normal. That's typical. I do things weird because I am weird, so I have extra email addresses. But if you only have the one, I don't believe GitHub shows you that drop down at all. Okay, so we're in our directory. Let's take some time to explore. Let's list the contents. We're going to see two things here. we're going to see our README, which is what we expect. But then because I have configured my settings to automatically print hidden directories, we're going to see a hidden directory called .git. This directory is effectively everything Git needs to know about the repository. So in there are a bunch of really wild files that track things like commits and your active branches and where your remote repository is. It's basically your settings directory for the repository. As a general rule of thumb, you never want to touch the Git directory. You don't want to edit things in there. You don't want to move it. You don't want to delete it. You want to basically treat it as its own little spider in the corner. Let Git handle that because it's very easy to break things if you try to muck around with it. So we have our README, and we know we want to change it. When we edited the file directly on GitHub, we committed straight to our main branch, which is our default branch. As a general rule of thumb, that is not a good practice. Say you are working on a contribution for freeCodeCamp, and you commit directly to your main branch. And you then want to go start working on another feature while you wait for your first change to be reviewed. You can't start that second feature because you don't have a clean default branch to start from. So we want to commit to a dedicated branch for the changes we are making. When we talk about branches, you kind of think of them like forks in the road. If you consider that the main branch is the highway, and it goes straight from start to finish, we might need to exit the highway to go work on some changes on the side and get back on later. We do that by creating a branch off of our main branch. Let's go ahead and try that out. You can use the git branch command to manage your branches. I prefer to take the shortcut and use git checkout. The git checkout command tells Git that you want to check out something else. You can check out a different branch, you can check out a tag, you can check out specific commits, but I generally use it just for branches. It's very rare that I have to check out something specific. So let's go ahead and check out a branch. We only have the main branch right now, so we need to create a new branch. And we do that with the -b flag, which tells git checkout we need a new branch. And then we name our branch. Let's call this docs contributing. We've switched to our branch. Let's take a look. We can see where we are at in terms of branches with just the git branch command. We'll see a new screen here, and we see two branches, our docs contributing branch that we just made, and the main branch, which is our default branch. The docs contributing branch has a star next to it, and in my terminal's case, also a different color, because that is the branch we have currently checked out. This is exactly what we would expect to see, so we're going to press Q to get out of this screen. Now, we need to edit our README. How you choose to edit files is entirely up to you. If I am making multiple changes, or I'm making a big change, or I am doing something where I need things like IntelliSense, or code formatting, or cool extensions to help, I'll open in VS Code. If I'm just editing a single file, quick documentation update, quick typo fix, that's where I use something like Nano or Emacs, something that's just right in the terminal. It's faster. I don't have to wait for all my extensions to load. I can just get it done. So let's open the README in Emacs. You need to use the no window flag and pass readme.md. There's our README. Let's add a subheading called contributing. And then let's add a quick description. This repository is a playground for you to use to explore Git and GitHub's various features. Please feel free to create issues, pull requests, and anything, typos again, anything else you would like to poke around with. All right, we are going to save that, and we're going to close our editor. Now we've made changes, and because we've made changes, our current local state is different than the branch state. Because right now, docs contributing is the same as main, because we created the branch from main. So let's see what we've done. Let's see what's going on here. We're going to use the git status command, and that's going to give you a bunch of information. It's going to tell you what branch you're on, which you can see here. It's going to tell you you have changes that are not staged for commit. This means that you have changes that you have made locally, but you have not told Git you want to include them in your next commit. So we need to stage those or add them so that we can get ready to commit them. And you can do this with the git add command. The git add command is pretty powerful. You can use it to specify a file, a folder, a bunch of files, a bunch of folders, or everything all at once. You can use patterns. You can do all sorts of cool stuff. I take the lazy route, and I use dot. Just add everything. It's important to understand that there are some potential concerns with that approach. For example, if you decide that Naomi has no idea what she's talking about, and you move the Git directory somewhere else, or you run Git init to create a new local repository in your documents folder, and you git add dot, it's going to add everything. And when it adds everything, that could be your entire documents directory. I do not know about you, but I have stuff in my documents directory that I never want anybody to see. I keep wild stuff in there. Thankfully, we have used the git status command, and it tells us exactly what we have changed. In this case, it says the only thing modified is the readme. So we can do git add dot. You don't really see any difference here. It doesn't tell you things worked. It doesn't tell you things didn't work. It just says cool. So let's look at our git status again. Now we can see that the changes are to be committed. This means that if we create a commit, the changes we have made to the README will be included. Maybe we don't want those changes. Maybe we decided to undo that. We want to save the README changes for later. We can get them out of the staging area using git restore. So if we do git restore -- staged readme.md, we're telling Git to pull it out of the staging area and put it back off to the side. If we run that, again, we see very little feedback. But if we take a look at our Git status, we can see that it is back to not staged for commits. Let's go ahead and put it back with git add, because we do want to include those changes. And then we need to create our commit. There are a couple ways you can do this. You can do git commit with a -m, and you can write the short message like we saw in the smaller input box in the GitHub UI. So we might do docs add contributing information, and we could create a commit just like that. I prefer to go the long way here and manually write the entire commit. And I'll show you why. So when we do git commit with no extra options, Git is going to open a new document in whatever default editor you configure. You can configure it to open this thing in VS Code. I've got mine opening in Emacs. You can open it in Nano. You can open it in Vim. If you are determined enough, you can probably open it in Notepad. I mean, there is a lot of flexibility there. If the text editor you want to use has a way to launch from the command line, Git can launch it as your default editor. So we've got a couple things going on here. First and foremost, we see this lovely little comment. Lines that are a comment start with a hash or an octothorpe or a pound sign, whatever you might choose to call it. These lines will not be included in the actual commit. These are comments typically automatically generated to help you understand what exactly you are committing. In this case, we see a reminder that hashed lines are comments and will not be included. They will be ignored. Git will remind us what branch we are on, and it will remind us what we are committing. That all looks good, and this is exactly why I choose to go the long way here and use this full editor so that I can double check one last time that everything that I want in the commit is in the commit, and everything I don't want in the commit is not in the commit. Because this all looks good, let's go ahead and write docs add contributing information. The first line of this file is going to be your commit message. It's the equivalent of that small little input box that we saw on GitHub. If we add more lines below this, we can write our extended description. So let's go ahead and just write, this is our extended description. We're going to save this. We're going to close it, and our commit is done. But our commit is still only on our computer. We need to push our commit up to the remote repository, which is the repository on GitHub that we cloned. There's some things to consider in this flow. First, we want to double check that we are going to push to the correct repository. A Git remote is the remote repository, which is the version of your repository on the cloud. So our GitHub repository is our remote. We can look at what our remotes are with the git remote -v, so we get all the information. And we're going to see we have two lines here. We have an origin, which is the default name for the remote that you clone from. We have the SSH URL that we cloned. And then Git tells us we use that remote when we fetch or pull. Git also tells us we use the same origin remote when we push. And that's what we want. When you go to push a new branch, by default, Git does not know where to push it. You can tell Git to be smart. You can tell Git, hey, just assume that I want to push my docs contributing branch to a docs contributing branch on the remote, which I have my Git automatically configured to do. But if you have not set that up, you need to tell Git manually. So we're going to git push. We're going to use the -u flag to set the upstream, which tells Git where this branch should go for the remote. We're going to tell it we want it to push to the origin remote, and we want to push the docs contributing branch. Git will probably complain if you try to push to a different branch. It will say refs don't match or something. You can kind of clobber that through, but honestly, it really makes no sense to do so. So make sure that the branch name you are pushing to is the same as your local branch, which I can confirm because I have my editor, my terminal configured to tell me. We hit enter, and we have pushed. So now our commit that we just made is up on our GitHub repository on the docs contributing branch. But that is only sort of half of the process. If we go back to our main branch being the highway, we have taken an exit off onto our docs contributing side street, and we need to get back onto main. with our changes. To do that, you typically want to open a pull request. A pull request is a request to the maintainers to pull your changes in. Let's look at what that looks like so we can kind of understand it better. If we go back to our GitHub repository, we see a helpful banner that sometimes shows up, but on a larger repository like freeCodeCamp, it takes a lot longer to show up because it has to do a lot more thinking to figure that out. We've got the handy little button, so let's just go ahead and click it. We click that and we get taken to our pull request UI. We're going to get a helpful message to read the contributing guidelines and whatnot, which this project doesn't have because we have not written them. So we're just going to get that out of our way. So we're going to see a few things here. The first is your pull request title. Your pull request title is kind of like a commit message, but for your entire pull request. When you are making a pull request from a branch that has a single commit, by default, the title will be the message of that commit. Our commit had the message docs add contributing information, so that's what GitHub put into the title for us. And that's great. We can leave that as it is because that is a great title. The description, when you have a single commit, is going to show the extended description from that commit. We wrote, this is our extended description, so GitHub has helpfully added that to the description field for the pull request. In this case, that's probably not enough information. So let's go ahead and explain why our changes are important. We'll take that out and let's say, these changes clarify how new learners from the workshop can interact with this repository. That explains kind of why these changes are important. That helps the maintainers understand why we want them to accept our contribution. Before we create this pull request, we can see a few other things here. You can request reviewers. So if you say, make a pull request to freeCodeCamp, you could request specific people to take a look at your changes. Sometimes GitHub will automatically suggest people. For example, at freeCodeCamp, we have it configured to automatically request the entire dev team as a reviewer. You can't turn that one off because we require it. But GitHub might say, hey, Naomi has edited these files recently. Would you like to ask her for a review? And so you can kind of add additional reviewers based on who you think or want to look at your pull request. When you're contributing to something as large as freeCodeCamp, generally you don't want to assign reviewers. You want to let whatever the maintainers have configured as the default just be. Sometimes you may be in a situation where someone asks you to add them. For example, if Jessica was talking to me here on Discord about a curriculum change and I was helping her determine the best path forward, I might say, hey, when you make that pull request, tag me for a review because I want to look at that and make sure that I've given her the right guidance and that we're both on the same page. But as a general rule, you want to be respectful of maintainers' time and not just ping people for a review. Have some patience. A lot of open source maintainers work for free and only on their spare time. We're going to leave the reviewer box empty just because there is nobody really to review this pull request. Now, because I have admin access to this organization, because it is my own organization, I can also set assignees. I can set labels, projects, and milestones. When you contribute to someone else's project, you probably won't have access to change those. But they might have configured some defaults, and we'll go into kind of how they can do that later. Before we finish creating this, let's scroll down. We're going to see that we have one commit, we have changed one file, and there's one contributor, because I am the only person who has pushed to this branch. Sometimes there might be more than one contributor. For example, if I am working on a curriculum change and I have my branch and I get stuck, I might push my changes up to my repository and say, hey, Jessica, can you take a look at some of these and give me some guidance? And Jessica might say, oh, I know exactly what needs to be changed here. Let me just push a commit. It will be quicker. So if she pushes a commit to my branch, when we go to make the pull request, we will both be marked as contributors. Below those metrics, you can see a list of commits. In our case, we have just the one. It's our docs add contributing information. If we click the 3 dots, we see our extended description. Naomi made the commit 10 minutes ago. And then we can see what's called a diff, which is a fancy way of saying the difference between the files. In this case, because we only added lines, we're going to see 3 pluses for the 3 lines that we added, and then we're going to see what we added. As we continue in this workshop, you will get a chance to see what it looks like when you're making changes that involve additions and deletions. But for now, this looks like the exact changes we made on our computer. So let's go ahead and make the pull request. Look at that. We have a pull request. As it stands right now, there is nothing in this repository configured to require reviews or run tests, and we'll cover that later. But for now, this is great. Let's go ahead and merge this. When we merge it, we're going to create what's called a merge commit. This is the default strategy in a new repository, and we'll cover some more of that later too. But for right now, we see an option to write a commit message. This commit message is for our merge commit. And we have an extended description which automatically populates with the commit messages from the branch. In this case, just the one, because we only have the one commit. This all looks great. We're not going to change any of this. Let's go ahead and merge. And again, because I have multiple email addresses, I pick the one I use for the merge. We're going to hit the confirm merge. Because I authored this branch, or because I have maintainer access, both of those will trigger this, I see a button to delete the branch. Since I made this branch, and since it's merged, I know I do not need it anymore, and I can delete it. This only deletes it on the remote. So it only deletes it here on the GitHub repository. And we'll cover how to delete it locally very soon. But let's go back to our main view. And we're going to see our new merge commit, merge pull request number 1 from NH Kerrigan docs contributing. And we can see that our readme has correctly updated. We see our contributing subheader. We see the cool little line we wrote. Everything looks great. Let's take a look at our commit history. And here, because we did a merge commit, we can see below our merge commit the commit we had already created. If we had a pull request that had, say, 5 or 6 commits, we would see all 5 or 6 commits here below the merge commit. We'll go over that again a little more later because we'll explain how the different strategies affect your Git history and why you might choose one or the other. But for now, this all looks great. The problem is, we want to make another change. We have a lot of cool stuff we want to do today. And if we go back to our local repository here, we're still on the docs contributing branch. So let's go ahead and check out main to switch back to the main branch. Because the main branch already exists, we do not need the B flag. We're not creating a new main branch. In fact, if we try to, Git will tell us it encountered a fatal error because the main branch already exists. But if we do git checkout main without the B flag, we're back on our main branch. Now, Git thinks that our main branch is up to date because we haven't done anything that would tell it otherwise. We know that our main branch has new commits on the remote because we merged a pull request. So when we want to update our local main branch, we want to pull those changes down. If you remember when we wanted to push our changes up, you can think of pulling as the opposite. We push up to the remote and we pull down from the remote. So let's do a git pull. Git will tell us a bunch of stuff, some logs about how it handles object changes, some fancy terms that honestly I've been doing for 5 years and mostly ignore anyway. And then we will see we pulled from our remote and we updated main. And we'll just get a confirmation that the changes included 3 lines added to the readme. The change summary can be helpful for things like projects where you have a dependency file, like a package JSON for a Node project or a requirements.txt for a Python project, where it's important to know that those have changed so that you know whether or not you need to reinstall the dependencies. Our little repository here is nowhere near that level. We know that only the README has changed. We're good. Let's take a look at our Git branch again, just to see what we've got. So if we do Git branch, we're back to this screen. We'll now see that main is highlighted and has a star because that's what we have checked out, but our docs contributing branch is still there because we only deleted it on the remote. We haven't told our local repository that we are done with that branch yet. So let's hit Q to get out of this screen, and then we're going to do git branch, and we're going to do -d, and we're going to pass the branch name contributing, docs contributing. The D flag says delete the branch. And there are actually 2 D flags. The lowercase d says delete the branch. But if Git determines that the branch contains changes that haven't been merged into your main branch, it'll say, yo, this has changes you don't have yet. You probably don't want to do this. If you use the capital D flag, that tells Git, no, actually, I know what I'm doing and I want this branch gone. Get rid of it. Don't care if it's merged or not. Get rid of it. In our case, we do want to make sure that the branch is merged, so let's start with the lowercase flag. Because we merged it in on our remote and pulled those changes down onto our local main branch, Git knows that the changes that are on docs contributing exist on our main branch, so it's safe to delete. So if we look at Git branch again, we just have the main branch, and that is exactly what we wanted. But how do we know what commits are actually on this branch? We're going to use the git log command to see a log of commits. Similar to the branch command, if we do git log, we're taken to a new screen, and we can scroll through all of the commits, from most recent to oldest. Thankfully, we only have 4 commits, so this is a very quick process. We can see a commit hash, super long string of numbers. Please do not try to memorize these. You don't need to. You can always go get them. We'll see that this commit was a merge. We'll see that Naomi authored it. We'll see when the commit was happened. We'll see a commit message. We'll see a commit description. If we look below, we can see the commit we authored locally and pushed. We can see Naomi wrote it, when it was committed, the commit message, and then our extended description. And then we'll see the other commits as we continue to scroll down. And then you see this initial commit. And the initial commit is a special commit. When you create a repository on GitHub and you say, yes, I want to start with a README, or I want to start with a git ignore, or I want to start with a license, or I want to start from a template, you have to have a commit to kind of create that initial state. So that's your initial commit. So we expect that because we started with a README. That's all okay. Everything looks good. Maybe we forgot. Maybe we aren't sure. Maybe we want to take another look. Maybe that is a lot of information to digest at once. Thankfully, we can do git log and pass --1 line. With this, instead of a massive wall for every single commit, we get single lines. We get a shortened version of the hash. We get some quick explanation of how the branch relates to where our various local branches are, or how our local branches relate to that commit. So our head, which is what we have currently checked out, is the same as main, which is on this latest commit. We have our origin main and origin head, which are on the latest commit. And then our origin docs contributing still says it's on that old commit. That's okay. That'll happen sometimes when you delete a branch and Git takes a moment to catch up. Everything looks good. We'll press Q to close it, and we are ready to make some new changes. Now, before we make some new changes, let's go back to GitHub and let's talk about some other features. One of the most important features when it comes to a repository are the issues. You can think of issues like tickets for work, but anybody can submit one. You do not have to be a maintainer. You do not have to be a member of the organization. If the repository allows issues, anyone can open an issue, unless you've been super naughty and got blocked, but we won't go into that. Issues can be all sorts of different things. You might use an issue to make a bug report. You might use an issue to make a feature request. You might use an issue to ask a question, though typically most projects will have some other platform for that, whether it's GitHub discussions, the freeCodeCamp forum, our contributors channel. You can always check a repository's documentation to understand when you should open an issue, when you should go somewhere else, and if you're ever not sure, you can ask the maintainers. But now that you have your own repository, maybe you want to control how and when people open issues. So let's take a look at what that might look like. We're going to start by trying to make an issue. We hit the new issue button. We see two options. We have blank issue, and we have report a security vulnerability. We're not reporting a security vulnerability. I certainly hope that a repository with a single markdown file does not have any of those. We're going to open a blank issue. And what we see is kind of similar to what we see for making a pull request or making a commit directly on GitHub. We're going to see an option to make a title. Our title should be a quick description of the issue. Unlike, say, a pull request, typically an issue title does not follow something like the conventional commit standards. But you should still kind of treat it like a commit in that you want a clear and concise description of the issue. We're going to open an issue to create some issue templates and forms. And we'll go over what those are. But for right now, we want to track that request. So let's call it create issue and PR templates /forms. And then the description is where we might include things like why it's important, alternatives we've considered, steps to reproduce if we're reporting a bug. In this case, we're just going to say Naomi wants to show us some cool stuff. We're going to make our issue. And the result looks a lot like the pull request screen we saw earlier because, and this is a kind of cool thing, as far as GitHub is concerned, pull requests are just fancy issues under the hood. So you can access pull requests through their issues API and do a lot of the same things with issues that you can with pull requests. Kind of neat. It really makes things, feel much more cohesive when you're trying to learn all of this stuff because it feels familiar. We've done our issue. We're going to leave it at that. If this were, say, an open source project like freeCodeCamp, you might wait for a maintainer to respond to the issue. Maybe Jessica responds and asks for more clarification. Or maybe my issue description isn't good enough to really capture why I think this is important, and she might come back and say, why do you think this is important? Alternatively, maybe my issue is great, it's straightforward, and it looks like something that can be a quick fix. And so Jessica might add a good first issue or first timers only on the freeCodeCamp repository to indicate that this is ready for contribution from somebody new. Or she might add the help wanted label to say this is open for contribution from anyone. Every repository will kind of use different labeling approaches, with the exception of good first issue and help wanted, which are kind of the standard and allow GitHub to better expose issues to people outside of your community, essentially. Right now, we're going to leave it with no label because we're going to work on this issue ourselves. So let's go back to our repository. We're going to create a new branch. So we want to git check out feat templates. But that branch doesn't exist. We forgot the B flag. Git tells us, hey, that path doesn't exist. We don't know what you're talking about. Figure it out. So we can do git check out B feat templates. And there we go. Now, in order to really get into this, we're going to have to edit a few files. And when I'm editing a few files, that's when I like to open this up in my full IDE. I use VS Code mainly because I work in .NET, and the .NET extensions don't work if you use something else like Cursor or Windsurf or even VS Codium, because Microsoft's changed their policies recently. So we're going to open this in code, and my terminal is configured that I can just write code. I have that aliased. But you could also open it through your application launcher, through your start menu if you're on Windows, through your own CLI command. I'm just using what works on my machine because, I've had lots of time to configure it. And because I can't really tell you what your command would be, it varies depending on your operating system, depending on what IDE you use, a lot of factors there. So you would open your VS Code or your Cursor or whatever, however you would normally do so. Now we see our workspace, and we can see we have a README file. And we can see that it looks like the README file we were expecting. GitHub allows us to define issue templates and pull request templates. These templates sort of act like guidelines or a starting point when people open an issue. And there's going to be kind of a lot we have to do to make those work. The first thing we need is we need a special directory for our GitHub settings. If you remember the .git directory, which you can think of as your folder for your Git settings, a .github directory is your folder for your GitHub settings. So let's go ahead and create a folder and call it .github. And we're ready for the next step. Our next step is going to be to add an issue templates folder to hold our issue templates. This folder specifically has to be screaming at you. You can't just say issue templates. You have to do in all caps issue _ templates. Because, everybody needs a folder that screams at them, right? Within that, then, you can define markdown files that sort of pre-populate that description field that we saw earlier. Let's go ahead and whip one of those up real quick. We're going to call this a feature report, or feature request, sorry. And I am going to cheat and go get the one that I wrote earlier. New tab, please. Slash Karen and repositories, and let me go back to here. And go to my issue templates and feature, and let's just copy it so that I can paste it in and kind of explain what we're looking at here. Issue templates use something, when you use a markdown file like we have done here, you need something called front matter. If you contribute to the freeCodeCamp curriculum, or if you use something like Next.js to power a blog site, or, there's quite a few projects where you might see front matter like this. And you can think of front matter as essentially setting a bunch of properties for your markdown document. In this case, we're setting a name for our issue template. We're setting a description for our issue template. We're creating a default title to pre-populate that title input. We're going to automatically add the enhancement label to any issue opened with this template. And we're not going to assign anybody to these issues when they are created. Normally, if I was setting something up like this on one of my projects, I would assign myself to every new issue so that I can triage them, determine the path forward, and open them for contribution. I am not going to do that on this repository because at the end of this workshop, I'm going to explain why that would absolutely destroy my notifications. So we're going to leave that blank. Below that, and our front matter is bounded by these 3 dashes to indicate the start and end of the front matter. Then we get into our regular markdown. And all of this is your standard markdown syntax. We have our subheadings, we have comments, and we've added some space for someone to write things. These comments will show up in the description box when somebody goes to open an issue, but they aren't included in the final rendered view when the issue is created. And we'll play around with these so I can kind of show you what that means. But for now, let's save this and move on. Aside from a standard markdown template, GitHub also has support for issue forms. So you can create a form for somebody to fill out for something like a bug report. With a form, instead of using a markdown file, you use a YAML file, or yet another markup language. A YAML file is going to feel somewhat familiar because it looks a lot like front matter, but more. Let's go ahead and grab our bug report YAML file. I'm just going to copy it, and we're going to add bug reports.yml and paste it in. Let's look at what we've done here, because there's a lot. At the top, we kind of see similar to the front matter in the markdown. We have our name, we have our description, which is actually called description in a form, which is nice. We have the default title, we have a default label we're assigning, we are assigning me. With YAML, if you want to assign multiple, you could do an array like we did for our label here, or you could add G. Wilkin 4. I hope I remembered. Honestly, it has been a long day. But, I could assign Jessica to every single issue that gets opened too. I don't want to do that because I don't want to blow her notifications up. She has plenty of her own stuff to work on. So we're going to just toss that line right on out of there. Below that is the body property. And this is where we really get into how these forms work, because there's a lot. Kind of like we saw with the assignees, we see that we have list items. But with YAML, your list item is indicated by the dash. So all of this is a single item. So our first item has the type set to Markdown, which indicates that we're creating a Markdown field. This field is displayed to the user when they fill out the form, but they can't edit it, and it's still included in the final result. And again, I'll kind of walk you through how that works. Below that is a text area. Nope, sorry, skipping ahead. We've also set attributes. We've given this markdown field a value. This is the text that will show up for that markdown section. In this case, we've started our line with a pipe symbol, which on a US keyboard is the one above your enter key, kind of on the / button. And that tells YAML we're throwing this on a new line. If we got rid of that, it would probably complain at me. Copilot really thinks we should put it there, because we should. Because in YAML, your value has to be on the same line as the property. Unless you tell it no. Or unless you have nested properties. So if we look at our next option here, we have a text area. A text area is a big input box for writing whole paragraphs with multiple lines. It looks kind of like the description box on that issue we opened. There was a lot of room there. We could talk for hours in that little box because it'll scroll and everything. In this case, we have a text area where the user can tell us what happened and explain what they expected to happen. So this is where we might want them to describe the bug. The label serves as the title for that input. The description will show up kind of like a subtitle for that input. So you'll see big letters for the title and regular letters for the description. And then you'll see the input field. You'll see a placeholder that shows up as that grayed out text when the input is empty, kind of like, the placeholder attribute of an HTML input element. And then you have the value, which is what we want actually pre-populated into that field. Then we have our validations. GitHub allows you to set various validations for your form. In my case, I don't usually use anything except required, which says the user has to fill something in this box in order to submit their issue. Below that, we define a drop-down field, which is like a select element in HTML. And we've given it a label, which again is the title. We've given it multiple set to true, which means the user can select multiple options. So it's, think like checkboxes instead of radio buttons, but in a select menu. And then we've defined 4 options for the 4 kind of most common browsers. Below that, we have another text area where we ask them to share any log output. We provide them a description, which you can't see. So let me turn on wrapping. And then we tell GitHub to render the result as a code block in the shell language, because most logs that you might see are going to be some kind of shell-like language. And then below that, we have checkboxes. And here we can set, again, options, like you can have checkboxes, multiple checkboxes. In this case, we've said that the entire thing is called Code of Conduct. We added a description saying that by submitting this issue, you agree to follow the Code of Conduct. And then we've added a single checkbox option with a label of I agree, and we've made it required. You have to agree to the Code of Conduct to open this issue. Let's go ahead and save that. This is a lot, and I am sorry. You'll get to see what this all looks like shortly, but we have one more thing to add. Just like we wrote a feature request template in Markdown, we can write a pull request template. The pull request template does not go in your issue templates directory. It goes directly in the GitHub folder. So we're going to create a new Markdown file. And like issue templates, we have to scream. So we're going to pull_request_template.md. And like you would in a feature request, you're going to have some Markdown and some front matter. I did not actually commit one because I reverted it. So let me go back in time here and get it. Add pull request template. We're going to view the file. We're going to copy it. And we're going to go back to our editor. Mostly because I don't want to make you all sit here and watch as I write this all by hand. And going through and copying a file is less important. I'm taking shortcuts because I did one of these this morning. In this case, we just have some markdown. We say it's a checklist. We add a comment that tells our contributors how to use the checklist. Won't show up in the final result. We have these cool little checkboxes. They can put an X in them to indicate that they have done them. If you had contributed to freeCodeCamp, this probably looks super similar because I stole this from freeCodeCamp and tweaked a couple of lines. So we have a checkbox to confirm they followed the contributing guidelines. We have a checkbox to confirm that their pull request targets our default branch because we don't want them making pull requests that target our other branches. That just gets messy. And then we have a pull request or a checkbox to tell them that says that they have tested the changes locally because we don't want people just pushing up code and making pull requests that they haven't actually confirmed work. And then we have this little closes thing. We're going to ignore that for now. I'll show you what that does in a minute. Let's go ahead and save this. So we have our two issue templates. One of them is a form and one of them is Markdown. And we have our pull request template. Let's go ahead and open our terminal. And we can use the one right in VS Code. Let's make it big and get some stuff out of the way here. And let's do a git status. See what we've got. We're going to see that we have a new GitHub directory. The status isn't going to tell us what's in that directory because the entire directory is new. We don't have one of those yet. Thankfully, VS Code allows us to open our file tree here. We'll make it a little bigger. And we can see that these green dots and then these U indicate new things. These are untracked changes. Untracked changes effectively mean that this is something GitHub has not seen yet, or Git has not seen yet. These are brand new files. It has not seen a bug report file. We didn't have one of those before, so they're new. They're not being tracked by Git yet. Our readme was not a new file because we started with it, so it was modified. Git was already tracking it. It knew that the changes were to be tracked. But a lot of this is kind of nitty-gritty. As a general rule, you probably won't need to know what the difference between untracked and modified is. You'll kind of get into that if you have to do some of the fancier stuff like git clean or modifying the git ignore, but I don't think we will have time for those in this workshop. So, untracked, think of it as just new file. Let's go ahead and hide that again so we can see our terminal here. We're going to go ahead and clear it just because it's a mess. Let's go ahead and add all of our changes at once. Let's look at our Git status again. Now we can see, because we have started tracking these files, because we have staged them for commit, Git now knows that we have 3 files and that they're all important. So we can see we have a new .github issue templates bug report, our GitHub issue templates feature request, and our GitHub pull request template. This all looks great. Let's make a commit and let's push this up. So we can do git commit. We're going to get our editor. We're going to do feat add templates. Save it, close it. Commit is made. Git push. Again, you would need to use the U flag. I have mine set up to automatically do that for me. We push to our branch. Let's go back to our cloud repository, our remote repository now. That's the wrong one. This one. All right. We hit code. We see our banner again. Let's make a pull request. We just worked on some really cool templates, but you won't see them in this pull request because they haven't been accepted. They're not merged in yet. So as far as the main branch is concerned, they don't exist. So we got to use our own. We're not going to write out that whole checklist again because that's a lot of work and I don't want to. But we are going to use that cool little closes thing. And here's how. We're going to write closes. Then we're going to write a pound sign. And we're going to get this cool little menu here. And we are going to say issue number 2. our issue to create templates, and it'll fill in number 2. Let's make our pull request. When we make our pull request, we can see that GitHub links number 2. If we hover over it, we get a cool little card that points to the issue. But what comes next is really what's important. We're going to merge this. We're just going to do our regular merge commit. Confirm, merge, done. We'll delete our branch. Now let's go back to our issue. We can click on the link. Because we used the closes keyword, once our pull request was merged, GitHub automatically closed the linked issue. This is super useful on larger projects like freeCodeCamp, where we have so many issues and so many pull requests, and it's just not feasible to keep track of all of them. When a contributor works on an issue and makes their pull request, our template asks them to fill in the number for the issue so that we know what work is linked to what ticket, and we can automatically close it when we accept those changes. Great stuff. Now we have our templates. So let's go make a new issue. If we click new issue, where are my templates? Hey, look, maybe Naomi messed something up. GitHub issue templates. It is issue template. Let's go fix that. Look at that. So we're in our terminal. We're going to git checkout main. Pull those changes down again. And I could teach you to revert, but I think we'll just fix it. We're going to move. We're just going to do it here. So hide the terminal, flip this back up, let Git refresh these because they are not deleted anymore. And where's my rename? Oh, way down there. Rename issue template. I'm going to be naughty and push directly to main. So we're going to git add, git commit. We're going to see nothing because it's so small. Hide this and biggen this. We're going to see that the 2 files are considered renamed because we renamed the directory, so the paths for the files changed. But we didn't change any of the contents. So as far as Git is concerned, it's a clean rename. So we're going to say fix Naomi made an oopsie. Save, close, push. Now that I've fixed that, if we go back to our Issues tab and we click New Issue, we should see our new templates. We see our bug report and our feature request. Let's start by making a feature request, because that was the template where we used Markdown with a little bit of front matter so GitHub knew what to do with it. So if we click that, we're going to see that title value that we set, which we can go back here and look at. Just go away. We can see we set feature, and we start with feature. That's right. What kind of feature should we add? Let's add a set up workflows. And so we can see our comments. So let's write make stuff go. Why is it necessary? I want it. Proposed solution, do it. Alternatives considered. Nah. Please do not make issues like this on real projects. I'm just not going to make you sit and watch while I type a bunch of stuff for no reason. If you make an issue like this on freeCodeCamp and you put in that bare minimum of effort, there's a very good chance that I'll have to block you from the entire organization. So make sure you take your time and write thoughtful tickets. I just want to get something on here so you can see the result. You can see the titles we defined because I didn't delete them. they were pre-populated and I left them alone. You see where I wrote stuff, but you can also see that all those comments that were in there that had the instructions of what to do, gone. They don't show up. If I edit it, you'll see them. They're still in there, but because they're comments, they don't render in the final view. That's great. That is exactly what we want. Let's take a look at our form. We're going to create a new issue again. We're going to look at our bug report. This one's different. This one is a lot cooler, honestly. I love issue forms. So if we go back to our file here, we see our title, bug, is pre-populated. And then we have to look at all of our body elements. The first thing we want to look at is this markdown that we set. We can see it shows up as a regular old text on the issue. This will show up on the final result, but the user can't change this. It's just there. Great place to stick some extra instructions or something like, hey, thanks for taking the time to report this. Any kind of messaging you want the user to see that they can't get rid of. Then we get to our text area. We called it what happened, we added a description, we added a value, and we added a placeholder. We can see what happened, we can see our little description, we can see our value pre-populated. If I get rid of it, you see the placeholder when the input is empty. Let's go ahead and just say stuff broke. Actually, you know what? Let's leave it empty. These little asterisks indicate required fields. The title is required. We've made this what happened input required. Browsers are not required. Let's go ahead and pick a couple. Let's see, I'm on Zen, which is a Firefox browser. But I also use Brave, which is a Chrome browser, so I see it on both. And you know what? Even though I'm on Linux, I use Microsoft Edge. And even though I'm on Linux, I made Safari work. Magic. We don't have any logs, but let's stick something in here. Git push. And then we have to tick the box. We can see our log output. In fact, I skipped ahead. So if we look at this browser field, and we go back here, we can see that we have a dropdown. What browser are you seeing the problem on? You can select multiple, which we did, and we saw all 4 options and selected them because we could. Then we see a text area for log output. It's not required, but we went ahead and put something in there anyway, so I can show you how it works. And then we see our checkboxes. We've given a label, the top level label attribute, which acts as the title of code of conduct. And we've given a description that's very long. We can see code of conduct. We've given our description. The link renders because it supports Markdown. It's very cool, very pretty. And then we see our one option we've established. It's a labeled with I agree to follow the code of conduct, and it's marked as required. We can see I agree to follow this project's code of conduct. Asterisk means it's required. We can see that the assignee is pre-populated to me because that's what we configured in the template, and the label that I added in the template also assigned. Let's try to create this. GitHub is going to say, haha, no, you can't, because we specifically said this what happened field is required. There has to be something here. You can kind of explore some of those validator rules. I think there are options to be a little more restrictive on what has to be here. I honestly don't know them all because I just make things required and go from there. So let's write, let's scream. We like screaming. With that, let's try to create the issue again. We have an issue. The end result we see is going to be the same kind of markdown we would see in any other issue. We have our what happened, we have our response, we have the browsers, we have our response, we have the log output, which because we said render or shell has automatically been formatted as a code block with the shell language. And we see our tick box that we ticked. If we edit this, you can see it's markdown. That's the end result. We did the fancy form so that we can kind of instruct contributors on what we want in an issue. But at the end of the day, the result is markdown. They can come back and edit their message. We can edit their message. Very neat, very cool, lots of magic. Let's go ahead and just save it as is. We're not going to edit it. Beautiful, looks great. Let's make a pull request. Let's go back to our thing here. And let's open a terminal again. And let's check out the feat code. Let's add some code. Let's add a JavaScript file just because we can. We're going to make a new file. I'm going to call it index.js. And we're going to write console log hello world because there we go. We have a hello world app. I could run this. Why not? Let's run it. Terminal's too small. Look at that. Hello world. Cool. Our program works. We tested it locally, which is one of the requirements in our template. Let's go ahead and push this up. Do a git status. We can see the, come back, index.js file is untracked. We're going to git add everything. Let's do a git status again, just because we like to be sure. It's in changes to be committed. Let's write a commit. We're going to just write a quick little message here. Feat add a JavaScript. We don't need the editor because we passed a message, and that is all a commit has to have. It has to have a message. Without the editor or bypassing the message, we don't have an extended description. It's either the D or the B flag you can use to add an extended description right here. We're not going to do that. It's probably arguably nicer to use the editor if you're writing more than just a quick little message. We've made our commit. Let's push it up to our branch. Git push. And let's go back. Like our last two branches, we see our helpful little banner here. We're going to hit compare and pull request. This time, we see our pull request template with all of the checkboxes that we worked so hard on. So let's take a look. Again, we see the instructions, put an X in the boxes like this. Ensures the team takes the pull request seriously. Very important if you're doing this on freeCodeCamp. Go ahead and mark an X. We are targeting the main branch. We can see up here the base is main, and we're comparing from our feat code branch. That's great. And we tested it locally. We ran the JavaScript. It did the JavaScript stuff. It was beautiful. And then we have, again, our section with the magical keyword closes. And we're going to close number 5, which was our bug report. But we're also going to say that this pull request is connected to issue number 4, but doesn't close it. So we can do that with the related keyword. And we can say related number 4. Not really related to the workflows issue, but that's okay. We're just doing some demonstrations here. Let's make our pull request. And let's go ahead and merge it. Yay! Merge, merge, merge. If we go back to our issues here, number 5 is gone because it's closed. It's now under the closed tab. There's number 5. Number 4 was not automatically closed because we used a different keyword than the closes keyword. But if we look at this issue, we can see that I mentioned it in pull request number 6. This is helpful for things where maybe I'm working on something that has some impact on another issue, but doesn't actually fix the issue. So I want the issue conversation to include a link to my pull request so that somebody who goes to work on the issue later knows that my changes might impact the approach they should take. Not really the case here, but cool to demonstrate. So let's talk about workflows. Workflows are super cool and very powerful special files you can use to define what's called actions. Actions allow you to run arbitrary commands and processes on things like every pull request or every commit to main. A lot of room there for some really cool stuff. They're also super complicated, so I'm going to try to give you a pretty basic surface level introduction. Let's go back to our repository and let's check out our main branch again. Going to pull our changes down so that we're all caught up again. And I'm just going to work on the main branch for this. In our .github settings directory, we need to create a workflows folder. This one is all lowercase. We don't have to scream here. But this is going to hold the settings files, the configuration files for the actions we want to run. Let's go ahead and take a look at freeCodeCamp's actions. They're going to be a lot. It's going to look overwhelming. I'll walk you through. We'll pare it down here. This is the file that freeCodeCamp uses to run our full test suite. We lint, we build the app, and we test. Run our unit and integration tests on every pull request. And I'll kind of show you how that works. But for now, I'm going to steal this whole thing. Just because I can. And we're going to create a new file. We're going to call it test.yaml. And paste. We're going to hide the terminal for now. And we're going to hide this for now. So we can see everything. We're going to start at the very top. The first thing is the name for the overall workflow. In this case, CI for Node.js. CI stands for Continuous Integration and is a term used to describe things like running tests on every proposed change so that you can confirm that accepting the changes won't break your application. Effectively, you're continuously integrating new code into your application. That's great. That sounds right. Let's leave that as is. Our next section is on. The on section allows you to define what GitHub events should trigger your workflow. In our case, we want to run this workflow on push, and we want it to run whenever a commit is pushed to the main branch. We do not need it to run on production branches because we won't have them. freeCodeCamp does, but our little repository here will not. So I'm going to clear that line. We also want to run it on pull requests. Same syntax, we specify the branches. In this case, we want to run it on pull requests that target our main branch. We're not going to have temporary branches, so we don't need to worry about that. Let's delete that line. Concurrency, something again for super big projects like freeCodeCamp. Kind of complicated. Honestly, I don't know everything about it. I do know we don't need it. Let's get rid of it. Then we have a permissions block. And this is where you can specify the permissions that the action has. In our case, we want it to be able to read the contents of our repository. But that's it. It can't write anything. It can't push commits. It can't close pull requests. It's just going to look at the repository and do some stuff. And that's great. We're going to leave that as is. Then we get to the meat of the file, which is the jobs section. This is where you define the specific tasks and each step those tasks need to run the logic you want to run. So let's go ahead and take a look at this lint block. Super long, loads of stuff, all configured to run a linter. We don't have a linter in this project. If you aren't familiar with what a linter is, it's basically a tool you can use to confirm that code written follows your whatever style guide you establish. For example, my linter rules might require that JavaScript has semicolons at the end of the line. or it might require some more complicated stuff, like I don't allow if statements all on one line, or I don't allow else blocks at all. I require early returns. This sounds complicated, can be complicated, not necessary for this project. We only have one line of code. So, delete that whole thing. We're just going to toss it. We don't need that job. Yeet. There's this big old comment here that says don't remove this job because we've left a note for ourselves over on freeCodeCamp where I stole this from that we need the build step. I don't need a build step here. We don't have a build step here. So let's toss the whole thing out. All gone. Goodbye. We have a test job. We do want a test job. We're seeing a whole lot of red here because this workflow was stolen, and originally the test job could not run until the build succeeded. Because if the app can't build, there's no reason to run tests. The app doesn't work. In our case, there is no build step. So this needs line here, where we would say needs the build job, don't need it. That makes the red go away. That's great. We can now focus on some other stuff. The name is the name for this particular job. It'll show up in the GitHub UI. The runs on is where you define the operating system that GitHub should use to run this job. In our case, Ubuntu 22 is great. Pretty much all of my apps run on Linux, so that makes sense. Ubuntu is a very common choice for server instances. We're going to leave that alone. Then we get into the strategy. This is where we can set some specific configurations for how this whole thing should run. I honestly don't remember what the fail fast does. I'm pretty sure it says keep doing stuff if a particular step fails. Could be wrong. GitHub has loads of documentation to check out to explore this. In my case, I don't know what it does, so I don't need it. Let's toss it. We'll see what happens. A matrix allows you to specify multiple values for something. In this case, we have a node version value, and we set it to a single option of 22. If I wanted to run my tests on node 22 and on node 24, so I could see, or on node 23, so I could see if the breaking changes in the latest node development version are going to impact my app when it reaches long-term support, we could add 23. We don't need that. I don't want it, so we're going to leave it as 22. Then we get to the steps. These are the specific commands or actions that your workflow will take. And there's going to be quite a bit here to look at, so we're going to take this a little slower. Kind of like we saw with the issue form, we're still using YAML, so our list syntax is still the same. This is a list item, and the next list item starts it all the way down here. So this whole thing is our first item. Each step gets a name, which shows up in the action logs. And then we have a uses property. And the uses property allows you to say, hey, go use this other action that somebody else wrote. In the chat, Jessica has linked, very helpfully, thank you, to the GitHub Action Marketplace, which is where you would go to, say, search for an action that checks out a repository. So it clones the repository in your workflow run. That's great. We can leave that as is. Because I stole this from freeCodeCamp and we have some automation to pin things to very specific versions, we have this nasty long hash. Chances are you won't use that, and you probably want at v4. Might just be at 4, could be wrong. I think it's at v4. Let's go look at the marketplace and find out. GitHub Actions Checkout. We're going to see view on marketplace because that will take us to the marketplace that Jessica shared and tell us how to use it. And we'll just scroll down here to actions checkout at v4. So that's good. We're going to leave that. With is where you define specific arguments that particular action we're using takes. One of the arguments that this one takes is a submodules property. This would allow you to tell the action to clone, including submodules. Submodules are really complicated Git repositories within Git repositories. Kind of a mess, kind of a nightmare, safe to ignore, at least for now. If you want to explore it, you can. Honestly, we have a submodule in our repo, and I screw that thing up all the time. I am always frustrated with that thing because submodules are very finicky. We don't need submodules here, so let's just toss that whole thing. Then we get to our use Node.js. Again, we can get rid of the hash and just use v4. And here's where we use that node version from our matrix. If we had multiple values, it would run this job for each value. So we would have use Node.js, matrix node version of 22. And, if I wrote 23 in there, we'd have another run for use Node.js 23. In this case, we only have 22. It's only going to run once with 22. Again, we're using an action from the marketplace. This one is actions setup node. Anything that comes from the actions organization is an official action published by GitHub themselves. As far as actions go, probably the safest and most reliable because they're officially supported. In this case, this particular action just handles installing and setting up Node.js and making it available for the workflow to use. That's great. We want it to do that, and we have to tell it what node version to use, and we'll just pull that from our matrix. This also means if I want to update my app in a year to use Node 24, I update the matrix version, and it works everywhere that we have matrix node version. I think 24 is out. I don't remember. Maybe it's not. No, I think it's October it comes out. So we're going to leave that at 22 anyway. And then we have a third-party action because it does not come from the actions organization. Copilot would like me to make it at v4, so we'll do that just to get it out of the way. So we see this one is from PNPM themselves. PNPM is a package manager for Node.js. It's an alternative to NPM, and our repository doesn't use any of those. So we don't need this step. Let's toss it. We have a step to set environment variables, copying from the sample. We don't have any of that. Don't need it. We have a step to spin up a MongoDB instance. Again, our app doesn't have that. Don't need it. We have install dependencies. Don't have those. We have install Puppeteer. Don't need that. We run some tests. We do want to run some tests, but we don't have a test command. So instead, we're going to use the pipe symbol so we can go on to a new line. We're going to indent. I changed my mind. I want to indent 2. And with a run step, instead of uses, where we're pulling somebody else's action in, a run step allows us to run shell commands. Because our workflow runs on Ubuntu, our shell commands will be bash syntax, just by default. You could probably find an action to install something like ZSH, or, I don't know, some other terminal thingy. But bash works fine. And all we want to do is node index.js. Let's just make sure that our hello world thingy does something. That's it. If there's an error, if it can't run it, it'll tell us. If it can run it, great. Now we have another job for test upcoming changes. We don't have any of that. Let's just toss the whole thing. We have one for test localizations. Don't need that. Let's toss the whole thing. And look at that. Our workflow is now 35 whole lines long. So let's review it. We have our name. We want it to run when we push to main or when we pull request targeting main, which all of our previous pull requests did because we wanted to pull the changes into main. It can read the contents of the repository, can't do anything else. We have a test job named test, runs on Ubuntu, runs node version 22, checks out the repository, sets up node, tries to run our index file. I don't know. I think that looks great. I think this should work. We're going to find out. We're going to save it. We are going to git add. We will embiggen this and we'll do git status. Our workflow file is there. Git commit. Feat add workflow. Save, close, push directly to main. Just because we can. Now, let's check out a new branch. We're going to call this test. And let's open our file again. And this time, let's add a console log. Naomi was here. And let's go ahead and save it. Commit it with git add, git commit. We're just going to do feat add new console statement. Push it up. We're on a test branch. Terrible name for a branch, but we're kind of getting close on time here. So let's go back to our repository here. We're going to check our pull request tab. We get our banner again. Ta-da! Add new console statement. This is all cool and all. We're going to fill out our checklist. We did not test it locally. We're going to leave that blank. We're going to say that this closes number 4 because once this is merged, or in order to merge this, we're going to check that our workflow works. Let's create a pull request. Now, before we would get the merge pull request button, and we still have it, but now you can see some checks haven't completed yet. And you can see that our CI Node.js action is running a test job with version 22 on the pull request event. If we click this, we can get the full action run logs. Let's take a look. We have GitHub sets up the job. This is where it provisions the virtual server to run on. It fetches the actions it needs. It makes sure that it has everything it needs. Then we have that checkout step where it runs actions checkout, clones the repository, does some stuff to make it work, cleans up some stuff, gets it all ready. Essentially, it has to do a bunch of extra steps to make sure that the clone works because this is considered an ephemeral environment. After the action is complete, the server is gone. It's torn down. It's just deleted. So, unlike, say, my laptop where I have a bunch of stuff already configured and stuff installed, an action runner doesn't have that. So the checkout action will take care of setting the runner up. Then we have use Node.js 22, which is out of our matrix. It runs setup node. It preps the environment, has node, has npm, comes with the yarn now, which is cool. Then we have our run tests. We see we ran node index.js, which is the command that we specified. We see our hello world line. We see Naomi was here. Nothing errored in that process, so the step completed successfully. And then we have a post job cleanup. We have a post checkout cleanup, all of which is just extra automated stuff that the action runner does to clean itself up. And we have complete job, cleans up everything else it needs, turns off the server, reports that the workflow completed successfully. And we get this beautiful blue check, which would be green on your machine if you don't use the colorblind theme that I use. So if we go back to our pull request, we can see all checks have passed. We can click the arrow. One sec. Okay, we can see that the Action has passed. We could click on it and look at the log again. But we're good. We have now made an action. Let's merge this. That'll close our issue to add actions because we use the closes keyword. We'll go ahead and delete the branch because we're done with it. And then we're going to do something really cool. We're going to go to settings here. And we're going to go to branches. And we're going to set up branch protection rules. And this is probably one of my favorite parts about working with GitHub. So let's make one. And I'll walk you through this. We're going to call this protection rule. We'll call it protect main. Because we can. We're going to set the enforcement status to active. That means that these rules are in place. And then we have a bypass list. A bypass list is where we can specify teams, people, roles, applications as exempt from this. So if I add myself, we'll add organization admin because I am. Because I am an admin, I do not have to follow these rules. Very helpful for things, where maybe an action gets stuck or something needs tweaking or something can go wrong and you need the ability to say these changes are fine, it's unrelated, merge it in anyway. So we'll add ourselves there. We need a target branch. In this case, we want to target our main branch, but that is also our default branch. So we're going to include the default branch. When we save this, that will update to tell us that it's targeting main. And now we have a bunch of rules. And a lot to cover. I'm only going to cover a few that I commonly use. Always recommend checking out the documentation if you want more information. We're going to prevent people from deleting the main branch because that would be very bad. That's our effectively single source of truth. We are going to require that people make a pull request. So we're not going to let people push directly to main. They have to make a pull request, and we have to merge it that way. I'm also going to say that all pull requests require an approval. This means that if Jessica has permission to merge pull requests, she can't merge her pull request until I approve it. This helps ensure that somebody has kind of signed off on the work and prevents us from accepting our own changes without any oversight. Sometimes I might approve something and then Jessica says, oh, wait, actually, I thought of a better way to do this. I'm going to push some new commits to the pull request because it's not merged yet. I don't want my approval to stick because not that Jessica would, but somebody could potentially push some really bad code and merge their pull request because it's approved and the rules are met. So I'm going to say that any pull request approvals automatically get dismissed when new commits are pushed. I am also going to require approval of the most recent reviewable push. A little bit of, double standard or double coverage here, but that also ensures that if I push to Jessica's branch, I can't review my own changes. Because she owns the PR, if she makes the pull request, she owns that. I can review it even if I push to that same branch and update the pull request. But if I require approval for my most recent push, that blocks me from approving my own work. And then we can require conversation resolution. This means that any outstanding review comments, whether they're suggestions or questions, all have to be marked as successfully resolved before you can merge the pull request. And then we have different merge methods here. We've been using the default merge, which takes all of the commits off the branch, creates a merge commit to track adding them, and just sticks them on main. That gets messy. If you've seen the history, you've seen a lot of merge number 1, merge number 5, merge number 3. I don't like that stuff in my repository. We also have a rebase method. which is very similar to merge, but without the merge commit. It basically takes all of the commits from the pull request, shifts them all up, and sticks them right on top of the main branch. That can also be good, but I prefer not to use it because the squash approach allows me to take all of the commits off of your PR, squash them into a single commit, and just put that commit on my main branch. That means if I have, say, an action that automatically releases new versions of my product whenever something gets merged into main, and I need specific commit messaging for my automation to know how and when to bump version numbers, I can take care of that when I squash. I do not have to make you take care of that in every single commit you write, because your commits are all going to get turned into a commit that I control. I find it makes for the cleanest history and honestly the best experience for everyone around, so I pretty much exclusively use squash. So that's the only one I'm going to allow. And then I can say we have to have status checks pass. Status checks are those actions that we set up earlier. So we're going to require that to pass. And we haven't added any required checks. Where is my check? Is GitHub just going to be like that? Okay. Well, if it was working, you would be able to select that Node.js test and add it to the required checks. So, and that's where you can say this pull request can't be merged unless the tests pass. That's probably the most critical piece of this entire workflow and branch protection setup is the ability to say tests have to pass, can't merge in broken code. Nobody can merge in broken code. I can because I bypassed myself. We're going to turn that off. If I could see the one on freeCodeCamp, I'd show you. Maybe I can see one on one of my other things. But we are going to block force pushes, so nobody can force push up to our main branch. And that should be enough. Let's go ahead and create this. I need to authenticate with a passkey, which means I need to unlock my password thingy again. Use passkey, sign in. Done. Our rule is now active. We can see that our default branch applies to main because that is our default branch. We're good to go. If you decide that one of these particular settings is not great, doesn't work for your workflows, gets in the way, too much noise, hate it, whatever, you can always come back and edit all of your rules. You can change. Now you can say, maybe I want 2 approvals. Maybe I don't want approvals at all. Leave that on 1. But you can always come back and change these. And so now, I'll leave the page because we already saved it. If we go look at this one that my dependency management thingy opened for me, we can see the check is passed, but it now says a review is required. Nobody has approved this pull request yet, and our rules require at least 1 approval. So GitHub calls that out. Because I am on the bypass list, I can tick the box and merge it anyway. I don't want to do that. In fact, we don't need renovate at all, so I'm just going to close that and let it go away. All right, that covers workflows and branch protections. And then real quick, kind of want to touch on projects. This is especially important for those of you who are participating in our hackathon. Projects serve as a way to organize all of your issues in a way that allows you to do some really cool stuff. So let's just create a basic one. We're going to use the team planning template because it looks like what we need. I'm not going to bother naming it. We're just going to set this up. If you've used something like Trello or Asana or another Kanban style board, you've probably seen to-do, in progress, done columns like this before. Difference is, here we can directly add one of our issues. Let's say that we want to add this pull request, because remember, pull requests are issues under the hood. We want to do that at some point. We want to set up renovate. We just don't have anything to renovate yet. So we're going to put that on our to-do board. And then let's go ahead and go back to our repository. Let's go to issues, and we will make a new issue. I'm just going to make a blank one. We're going to say better contribute. Yay. Again, please don't create these low effort issues on real projects. That just makes extra noise, and I don't want to have to ban you from freeCodeCamp. That would be sad. Nobody likes that. I don't like it. You don't like it. Nobody likes it. But now we can add our new issue. And, you know, maybe I'm actually working on this. So I'm going to just drag it right over to the in progress column because I'm doing it. Not really, but we're pretending. Projects also allow you to do some really cool stuff. Like when you assign issues, you can assign points if you're from the Agile world or the Scrum world or the Jira world. You can assign points, you can assign priorities. You can essentially leverage some of these to kind of determine the workload and capacity for each member of your team. So, I could look at issues I've assigned to Jessica and look at their priorities and their point values and whatnot and get a sense of whether or not I'm over or underworking her. You can also set a roadmap, so I could set dates for when these should be, when work should start on a ticket, when work should end on a ticket. I can see a view that is just items I'm assigned to. A lot of cool stuff that you can do with projects. Again, one of those things where I really recommend checking out the documentation, because in order to cover everything that these projects can do, I would have to keep you here for another million hours. So again, plenty of cool stuff to do, plenty of cool stuff to explore. And now I'm going to break my rule. I've spent this entire workshop telling you, hey, don't make low effort issues. Don't make bad pull requests. Don't go bother a bunch of maintainers, on a repository like freeCodeCamp. This repository, though, this freeCodeCamp GitHub Workshop number 2 repository, which I'll link in the chat when I am not actively sharing my screen. This is your playground. This is my gift to you. You can use this repository to practice things like forking, which is making a copy of the repository under your own account so you can push to branches and make pull requests back to my repository. You can use it to make issues. You can use it to make pull requests. You can use it to explore anything you can explore and kind of just get comfortable with some of the contributing flows. Unlike something like freeCodeCamp, if you come into this repository and make a low effort issue or a low effort pull request, I'm not going to block you. That's what this is for. This is where I want you to practice using Git and GitHub so that you can do so in a place where you aren't going to bother maintainers, and so you can get comfortable and start to really build up those skills to get ready to contribute to something like freeCodeCamp. With that, I would now like to open up the floor. If anybody has any questions, you can raise your hand to come up on stage and ask, or you can drop it in chat and I can read them myself, because I have chat on the gaming computer where I am recording all of this. And I'll give folks time to type. Need background music, but I want to be able to put this on YouTube, and I don't want a copyright strike, so. Also, my music is on my work laptop. I don't know if that'll come through the screen share. I actually have no idea if audio works. Linux is weird about screen sharing. It's always been a nightmare. Ooh. gracious. I do see folks typing, so I want to give them the time to do so. And I think, let's see, requests. If somebody wants to request, yeah, I can see requests. Hey, more than happy to take the time to do this. Like I said, this really started as kind of, I saw a lot of people in the hackathon who weren't quite sure how to use Git. We're ramping up. That starts on Monday. So I wanted to sneak in some workshops and a bunch of different times so that as many people as possible could come. But again, this seems like some really cool stuff that I think everybody could benefit from, so I wanted to open it up to our entire community. Maximus, yes, there will be a recording. My audio is still coming through. My OBS is going strong. I've got 2 hours of recording. It is going to take me some time to get this cleaned up and published on YouTube. I am more than happy to share it in the server. I'll do a big ping so everybody can see it. I'll have a bunch of recordings all at once. But I can't promise that this is going to happen anytime soon. It's already 10 p.m. here. I've still got dinner on the floor to eat. And I have to turn around and do another one of these in a few hours. So, won't happen right away. But I do have the recording. I promise I will get it to you. I don't know if I'll get it to you before Hackathon, but I will really try. I just can't make any commitments. I just need to go double check and make sure I didn't screen share anything that I shouldn't have. But I think I'm okay, and I think I can do this with minimal editing and at least get it uploaded tomorrow. I think. No promises, but I am going to try my best because I know lots of you are waiting for this information to help you prepare for the hackathon, and that's in 2 days. I just can't make any promises because all I know. Yeah, absolutely. If you have a companion notes, I can publish it either as an announcement or I can slap it up somewhere. Actually, I might be able to push it through as an article, but I'm not sure. What we might do is I'll publish it as an announcement for the hackathon just on Discord, just to get us ready for Monday. And then you and I, Jessica, can, or you can, and I can help you get it published, turn it into an actual news article so we can publish it for the broader community. Maximus, you can absolutely join the next session. There are actually 2 more. I have another one in about 10 hours. It'd be 8 a.m. my time. And then another one at 8 p.m. my time, which is the same time that this session started. You can see them in the events tab on our Discord server. The times for those events will automatically show for your time zone, thanks to Discord magic. I am so glad I am not the engineer that had to build that. That sounds like a nightmare. But somebody really cool built that, and it works. So yes. And again, I will send out the same automated notification when I start the next 2 events. You are more than welcome to come visit those. I am trying to cover the same stuff in each of these so that everybody who shows up to only one event can still get all the same experience. But it's a great opportunity to kind of help solidify that knowledge if you've got the time to attend more. And you might have new questions next time too. Yeah, the people at Discord are awesome. I've known a few of the developers at Discord, and it's just wild. It's cool. I love hearing stories from other developers. It's so much fun. Anyway, I do think that should be about it. You are all always welcome to ping me in the Discord chats if you have questions, need extra guidance. More than happy to support you as we take this learning journey together. But for now, I'm going to go ahead and end the event. It's been real. It's been fun. It's even been real fun. We'll see you next time.